chapter, we're going to look at what types of data structures you might want to use depending on the code that you're going to do. And we're going to look at two different ways of looking at variables. One, aliasing, and the other is mutable versus immutable. So an alias is just when you have an object and you have two different names for that object. Mutable versus immutable is really when you make an alias. It's a question of whether you make an not when you make an alias. When you perform an operation on data, do you create a new version of that data, or do you use the data that you already have? So when you create a variable, you are reserving memory for that variable. And with certain kinds of objects or data, when you do an operation to that data, then it actually creates a new piece of memory and puts the new version in that new piece of memory. But other data types, when you change them, it changes them where they are. So data types where it creates a new piece of memory when you perform an operation on that data type are called immutable. Data types where it makes the change in place are called mutable. And it makes a difference. It can make a difference in what variables or what data types you want to choose. So we're going to take a look at some examples of immutable versus mutable. So ints and floats are immutable. So I'm going to start off with declaring a variable x to be 2. So this is an integer 2. And then I'm going to create an alias for x, 2. Now those two things, alias for x and x, both are pointing to the same piece of memory at this point. And you can check that because you actually have an ID associated with any piece of any variable that you create in Python. So I'm going to print out the IDs for these two variables, and at this point we'll see that they're the same. Then I'm going to take x, and I'm going to add 3 to x. Because x is an integer and it's immutable, when I add 3 to x, it's actually going to allocate a new piece of memory for this new integer 5. And we're going to see that because we're going to print out the ID for x and alias for x. And the ID for x is going to change. So x is going to be pointing to a new piece of memory, whereas alias is going to be pointing to the original piece of memory that stores 2. And then we're going to print out x and alias for x. We're going to do a very similar thing with strings. Strings are immutable, so I'm going to start off with a string s. I'm going to make an alias for s. I'm going to print out their IDs, and at this point, their IDs will be the same. And then I'm going to add to the string s, aren't they? I'm going to print out the IDs again. In this case, we'll see the ID for s has changed because strings are immutable, and I've made a change to s right here. And then we'll print out s and alias for s. Lists, on the other hand, are mutable. I'm going to start off with a list L, and I'm going to make an alias for L, print out their IDs, and then I'm going to make a change to the second entry in L, so this is going to become an 8. Print out the IDs, print out L. I'm going to append something to L, and again we'll print out the IDs, and we'll print out the two lists. Tuples are immutable, so it's the same process. I'll start off with a tuple t, make an alias for it, print their IDs. We're going to add an element 5 onto the end of that tuple, print out the IDs again, and because tuples are immutable, we're now expecting this ID for t to have changed from before, and we'll print t and alias for t out. Dictionaries are mutable. So I'm going to start off with a dictionary, create an alias for it, print the IDs. I'm going to make a change to the dictionary. We're going to redefine the key value 1 to be E instead of A. It's going to kind of screw up the alphabet, but that's okay. Print out their ID values. In this case, because dictionaries are mutable, we're going to expect these to have the same ID. Print D and alias for D. We're going to update. We're going to add to the dictionary D. So we're going to add in a keyword 5 with a value of F. Print out the IDs for D and alias for D again. And again, we're expecting these IDs to be the same, and we'll print D and alias for D. All right, so let's run this. We'll go up here to the beginning. So ints and floats should be immutable. So here's the ID number for x, and here's the ID number for alias for x. Let's go back up and look at our code. And then we make this change and we add 3 to x. And notice the ID for x has now changed. It's pointing to a different piece of memory now. Whereas alias for x is still looking at that number or pointing to the memory. We've got to be careful using the word pointer, but it's pointing to the memory spot where the number 2 originally was. And then if we print out x and alias for x, we get 5 and 2. Strings, immutable. So we print off the ID values for s and alias for s. We make a change to s, and now this is pointing to a different piece of memory. And then we print off s. S has changed. Strings are immutable, aren't they? Alias for x is not changed. It's still pointing to the original string. Strings are immutable. And here's where it gets interesting. Lists are mutable. So we make this change to this list L. And we make L1 8. And notice that the IDs here have not changed. So this change in this list occurs in the memory that was originally allocated for L, which means that not only does L change, but alias for L changes also, since they are both pointing to the same piece of memory. And if I make another change and append on 5 to that list, remember that both of these lists are pointing to the same place, and lists are mutable, so it affects both of them. So this is the kind of thing that you need to keep in mind when you're writing programs. Because if you don't keep this in mind and you make a change to one list and you call another list the same thing, you may not be expecting that second list to change. Well, it's going to. Lists are mutable. Tuples, on the other hand, are immutable. And so tuples and lists have a lot in common, and so you might want to think about when you're using one versus the other is this idea of mutability versus immutability. So I made the change to the tuple, and its ID number changed, and the original, or T, we see now has an extra element in the list 5, whereas alias for T is still the original list. Dictionaries are mutable. So I make a change for the dictionary. And again, the IDs stay the same. So D points to this original dictionary. Alias D points to the same dictionary. And when you make a change to D, you're also making a change to alias for D. So if I change the first keyword to have a value of E, that makes that change in both of those dictionaries. And if I add a new key, then it gets added to both of those dictionaries. Now this idea of mutability is important also when you're working with functions. So I'm going to come over here and I have a bunch of functions that basically do the same thing. We're going to talk about this import copy here in a minute and what that does. Import basically brings in some more Python packages, and there's one I needed here to show you. So I'm going to define add number. Basically what these functions do is they just make a change to a certain kind of data type. So add number is going to make a change to a number. It's going to add 2. Add string is going to take any string and just append on the word new. Add list is going to append 1 to that list. Add tuple is also going to add 1 to the tuple. And add dictionary is going to add to whatever dictionary is passed to it a keyword of Jim with a value of supervisor. All right, so let's run this and see what happens. So I'm going to start off with an integer 5, and I'm going to add number to 5. And I'm going to print off this value of add number, and I'm going to print off the original value A, or so I think. And this add string is going to add old. It's going to add, so this is going to add 2. I'm going to add new to that string and print off add string and the original string. Same thing with the list. So I'm going to start off with list 2, 3, 4, and add list, remember, appends the value 1 to that. And then I'll print off the added list and the old list. Add tuple also appends 1, so I'll print off that list with a 1 appended to it, and the original T and this dictionary has 2 entries in it, and we're going to add to that Jim as a supervisor. So what has happened? Well, if we come up here, we get what we expected. We print off add number, and we get 7, 5 plus 2. We print off A, and we get 5. So that's completely expected. We start off with a string old. We print off add string, and we get old new. And then we print off B, and we get old. So that's the original string old, exactly as expected. Then something interesting happens. So we have C as the original list 2, 3, 4. Remember that lists are mutable. And we call add list C, which then appends the number 1 to this list. And so we print off add list C, and we get the list we expect, 2, 3, 4, with a 1 on the end of it. But then we print off the original C, we get the same list. So what has happened is we've made an alias for C when we called add list. That alias changed, and because the alias changed, it changed the original C. So this is important because when you call a function with a list, you better understand that that function could change your list in the calling program. You may not be getting a new copy back. It may be changing your original list. Tuples do not. Now this could be desirable or undesirable. You just have to know or expect this kind of behavior from lists. Tuples, on the other hand, because they're immutable, if you make a change to a tuple in a calling procedure, then sure enough, add tuple will have that 1 appended to it, but the original T won't because it's immutable. Lists, again, are mutable. So I call with D and add dictionary to that, and sure enough, it adds Jim to that. But not only does it add Jim to the add dict version, but it also changes the original D version. So again, can't say this enough, dictionaries are mutable. Now, it is possible to avoid making these changes to mutable lists or dictionaries, so I should say mutable variables here. Here's an example where I've created 2 lists, E and F, and I print add list E and E. And notice that it makes that change to both E and add list E, so it adds another 1 on the end of it. But when I call add list with F, I actually make a copy of F. So here's a way to make a copy of a list. And when I make that copy, this is actually creating a new piece of memory for F using array indexing, but you just don't put an initial value here before the colon or an initial value after the colon. So this creates an actual new piece of memory that's then called and passed to add list, and then that list is changed. So I get the 1 appended onto it, but the original F is unchanged. So there is a way that you can call functions with mutable variables and not have them changed if you don't want to. And then the same thing with dictionaries, and this is where I had to invoke that import copy. And so what you do is you make a deep copy of your dictionary, pass that deep copy to the function, and then the deep copy will get changed, and the original will not get changed. Okay, so hopefully this isn't too much information, but the idea here is when you have to make a choice between what sort of variable type do you want to use to represent your data, and you're choosing between lists and tuples and dictionaries, one of the things to keep in mind is the mutability aspect. And one last thing, looking at the difference between a list and a tuple, and this is probably a small and subtle difference at this point, but because lists are mutable, they have what are called methods. So L is a list, and as a list, it has a sort method associated to it, so we can call L.sort. T, on the other hand, being a tuple, there actually is a sorting routine for that, but you have to call it separately, and we can call sorted T. Not sorted, but sorted. The interesting thing is, when you call L.sort, because that list is mutable, when you print off L, L is now sorted. T, on the other hand, will not be. So again, one of the things, even though we've printed off a sorted version of T, notice that it returns that as a list, not a tuple. So again, just pointing out some of the differences between mutability, immutability, and aliasing, some of the things that can influence a decision as to what kind of data type that you use.